let's start off with the combustion reaction. In combustion reaction, what actually happens is you are burning in the presence of oxygen, and if you do not have oxygen, you cannot burn, and hence this is also a kind of a oxidation reaction. So let's take an example of this combustion reaction, and then we'll try and understand what is the importance of this combustion reaction. Now, in a combustion reaction, let's take an example of methane, which is CH4. When you heat it in the presence of oxygen or burn it, what you get is CO2, which is carbon dioxide, and H2O. But alongside, what you also get is some heat, and you also get some light. Now, if you look at this, what other byproducts are in terms of its energy, you get light. Now, this light is an important factor when it comes to judging what kind of a hydrocarbon do you have in your spatula which you are burning. So, whenever you heat an unsaturated hydrocarbon, what happens is you get a kind of a yellow flame with some black sooty flame. Now, when you have a black sooty flame, this suggests that you have an unsaturated hydrocarbon. That means there was more space for it to add hydrogen to it. And then when you have a saturated hydrocarbon and you heat it on a flame, what you get is a clean flame. And this is one of the basic tests that you can use so as to determine if your hydrocarbon is saturated or unsaturated. Now, if you've seen the combustion reaction, you've understood that that is also a process of oxidation. But over here in this oxidation process, we are now going to heat it or burn it. So, how do we get our substance to oxidize over here? So, over here we have ethyl alcohol and we want to oxidize it. So, what we are going to do is we are going to use something called as an oxidizing agent. Now, this oxidizing agent is nothing but a substance which itself would undergo reduction and would force the other compound to oxidize. So, let's see how this will happen. So, you have ethyl alcohol which is then reacted with an oxidizing agent which may either be alkaline KMnO4, which is potassium permanganate, or acidified K2Cr2, which is chromic acid. Acidified K2Cr2O7, which is chromic acid. Now, this reaction actually happens in steps. The first product that you would usually get is an aldehyde, but this reaction does not stop at an aldehyde, it continues and further reacts to give you a carboxylic acid. Now, let's just look at the structural formula of ethyl alcohol, which is ethanol, and carboxylic acid. Now, if you see, there is 3 hydrogens on the first carbon, 2 hydrogens on the second carbon, and an OH group. Now, if you look at the carboxylic group, you can see that there are 3 hydrogens on the first carbon, no hydrogens on the second carbon, rather you have the addition of an oxygen and you have the OH group as it is. So, there are 2 things that have happened. Number 1, you have lost 2 hydrogen atoms and you have gained an oxygen, and while the basic definition of oxidation is nothing but gain of oxygen or loss of hydrogen, over here we have had the loss of hydrogen as well as the gain of oxygen.